Hello everyone, in this video I'm going to show you how to conduct a paired samples t-test in JASP. First we're going to go over how to check that your data meet the assumptions to conduct the test, and then we're going to talk about how to analyze and interpret the test results. If you don't need to know how to conduct the statistical assumptions, feel free to skip ahead in the video after I explain our data set that we'll be working with today. Remember, when we're running a paired samples t-test, we're essentially comparing two means to see if they're statistically different from one another. Those two means can come from a couple of different scenarios. They can come from one group of people who are exposed to two different experimental conditions. It can come from one group of people measured at two different time points, or from two different groups of people that are matched on specific criteria. And so essentially they need to be related or paired in some way. For our JASP walkthrough, we'll be analyzing data published by researchers Al-Buha and colleagues in 2019. They conducted a series of studies to better understand the impact of identity denial on people with either bicultural or biracial identity. And I'll explain more about what that means. We will only be analyzing a portion of their overall study, so check out their publication to learn more about their work. Let's talk about what identity denial is. People commonly associate being American with being white. This excludes several groups of people, including Latino and Asian Americans, who are American but are often perceived as foreigners. This comic shows how this is often experienced by Asian Americans through the question, "Where are you from?" or its follow-up question, "No, where are you really from?" The researchers defined identity denial as being denied membership in a cultural or racial group that is relevant to how people identify themselves. For the study data we will be working with, they study people with bicultural identity, meaning they identified with two cultures, and they also studied people in study 2 with biracial identity, identifying with two races. For example, in the image to the left, it shows a biracial woman on YouTube who discussed her experience being told she wasn't black enough by a brand that she had worked with in the past to promote their products. So let's get to know the data we'll be working with. Al-Buha and colleagues recruited a final sample of 126 bicultural undergraduate students. Students all identified as Asian, 56% were women, and although there was one born outside of the U.S., all participants were U.S. citizens. The outcome variables that the researchers looked at included measures of stress, cortisol reactivity, affect, and more. We will be focusing on their measure of perceived stress for our example. The researchers for this study used an experimental research design. We will only be looking at one condition in order to conduct a paired samples t-test for this example. For this study, potential participants first completed a pre-screen survey. People who identified as bicultural respondents were invited for the study. When students came in for the study, they completed a baseline study measures, including stress, cortisol levels, and more. After they completed those, a second experimenter came into the room and said, "Actually, you have to be American for this particular health study." This was a bicultural identity denial, since all of the participants were indeed Americans. They followed it up saying, "Well, because you've already started the study, I think it's okay if you continue, but I'll make a note about it in my records that you're not actually American." After that, they had all of the students complete the study measures a second time around. For our walkthrough, we'll be analyzing the data from Al-Buha and colleagues' study to determine if there are significant differences in student levels of stress before their American identity is denied and after their American identity is denied. So we'll be looking to see, are there changes in those mean levels of stress at time 1 and at time 2. Our null hypothesis for this study is that there are no significant differences in self-reported stress before and after experiencing identity denial. Mathematically, what that means is that we expect that there will be no mean difference on that stress. So the mean difference, as notated as MD, is going to be equal to 0. There's no difference. Our alternative hypothesis is saying that there is a significant difference in self-reported stress before and after experiencing identity denial. And mathematically, what that means is that we expect the mean difference on time 1 to time 2 to not be equal to 0. So you can see that notation there, MD, not equal to 0. Before running a paired samples t-test, we have to make sure our data are appropriate for this analysis. To do that, we have to meet 4 different assumptions. So we're going to go through each of these assumptions on the screen and talk about what they mean. So the first one is that we need to have a categorical independent variable with 2 related groups. So they need to either be in the same group or they need to be matched or related to each other in some way. In this example, we need the students who completed the study measures before the experimenter came in and denied their American identity to be the same students who completed the study measures after their American identity was denied. In this case, we meet this assumption. Our second assumption is that our dependent variable, stress, must be continuous or measured at the interval or ratio level. Participants rated 4 items assessing their level of stress on a 7-point Likert scale that was used to create an overall scale average for each participant. In psychology, we generally treat Likert scale data as continuous, thus we can say that we met this assumption. We'll need to move to open our data in Excel and JASP to check the remaining assumptions. However, I want to point out that our remaining assumptions require that we know a little bit about difference scores. So let's briefly note what a difference score is. So to calculate a difference score, we will subtract the time to total level of student stress from students' level of stress measured at time 1. We do this calculation for each participant. This will give us the ability to determine if the different scores, time 2 minus time 1, are normally distributed and whether or not there are any outliers. So let's open Excel first to learn how to calculate a difference score, and then we're going to jump into JASP to analyze our data. So I've opened our data set up in Excel, and what you can see here are we have a total of 4 columns right now. So we have our case ID, we have our condition, so whether or not they were in the condition that we just described as having that American identity denial. And there was a second condition that we're not going to be looking at. And then this is stress time 1 in this column, and then this is stress time 2 in this column. So what we want to do is we're going to create another variable, and we're going to call it difference underscore stress. And you can rename it other things. That's just what I'm going to do for this example. So what we need to do is we need to ask Excel to subtract time 1 stress levels from time 2 stress levels. So I'm just going to scroll in a little bit to make this a little easier to see. So if we go in this particular cell here, we're going to put equals, and I'm going to hit the control key and hold it down and click on time 2 data for this particular participant for case ID 1. And then I'm going to write minus, hold control down again, and highlight time 1. And after this, you'll see it says equals D2. This is the column and the row that's in. D2, that's just defining that cell, minus C2. So that's telling us minus this cell. Once you have that in there, equals D2 minus C2, you can hit enter. And what has done is it has taken 7 minus 5.75 and calculated it. So we need this for all of our participants. So what you're going to do after you've done it for one participant is you highlight that cell, and you can see there's this box that comes up in the lower right hand column. So you're going to hover over it until you see a little cross appear, and we're just going to drag it down. And I'm sure there are other faster ways of doing this, but we're just going to drag it down to our last participant in row 127, and you can see it will auto-populate that equation into all of these. And so if you were to highlight this cell, for example, it tells you equals D127 minus C127. So now we have the different scores that we need in order to go into JASP and to look for outliers and to check to make sure that these different scores are normally distributed. So let's move into JASP next. So I have our data set open up in JASP now. You can see we have 5 different columns. We have our case ID, we have condition, stress time 1, stress time 2, and our difference scores that we just calculated in Excel. So the very first thing we're going to do is we're going to click on condition. So here, these labels mean different things. So the label of 0, this actually means control. This is our control condition. And the label of 1, this is the denial condition. So people who are in the denial condition, those are the participants who had their American identity denied. We are only going to be analyzing participants who are in the denial condition, so we're going to filter this data out. So to do that, we're going to click on this check mark here, and what you'll notice is that anyone who is in that control condition now has a lighter gray text color, and so we're not actually going to be analyzing their data. So once you have that X for the control condition, you can click on the X, and now we're going to go up here to descriptives. So because I want this to be a little bit bigger in the screen, I'm going to click on this arrow right here, and what we're going to do is I'm going to move the difference score over here to the variables box. So we have 2 more assumptions that we need to check, and to get those assumptions, first, we want to check for whether or not our difference scores are normally distributed, and we're going to click on skewness and kurtosis to get that information, and you'll find that under the Statistics tab. And we're also going to look under customizable plots, and this is where we can get box plots that will help us identify outliers. So click on box plots and then click on label outliers there. And this will give us the information that we need to check for our remaining 2 assumptions. So to check to see are these difference scores normally distributed, we're going to look at skewness and kurtosis, and we want to make sure that those are between a -2 and a +2. So we have skewness here of 0.537, and we have a kurtosis value here of -0.634. So the closest those numbers are to 0, the less skewed they are. And so we are happy with those. They're between our boundaries of -2 and +2, so we meet that assumption. Our data are normally distributed. And for the last assumption, we want to make sure that there are no outliers in our difference scores. So for that, we're going to look at this box plot. If you ever want to make an image in JASP larger, you can just hover over and you'll see these 3 lines come up in the bottom right-hand corner, and you can drag that to make it bigger. So box plots, this is showing us how our data are distributed across 4 different quartiles. This is the median value here. And if we had outliers, we would see circles with participant numbers labeled outside these whiskers. So outside up top here or outside down below here. And we don't have that here. So we meet this assumption. There are no outliers in our difference scores. So now we can move forward and go ahead and run our paired samples t-test. So we're going to go up here to the top to the t-test, and we're going to click on paired samples t-test. So to do this, we want to move, you can see this box here, it says variable pairs. So we're going to move stress time 1. We're going to highlight that and click the over arrow, and then we're going to hit stress time 2 and hit the over arrow. And so now we have those paired stress levels, time 1 and time 2, in our variable pairs box. A couple other things that we want. We also might want to have and report confidence intervals, and we definitely want to report effect size, so that's the Cohen's-d value, and a couple other things there that you can click on down here. You can get different types of box plots, descriptive plots. I like to click on the descriptives. That gives us the means and standard deviations for each of our time points. And I'm also going to click on descriptive plots because that just helps me as a researcher to be able to visualize the data and what's happening. So once I have those things clicked, I'm going to go ahead and move this over so I can see it. So when I'm teaching this, I generally have students start by looking at these descriptive plots only because it helps you get a visual of what's happening with your data. So here, this is the mean level of student stress at time 1 before an identity denial, and then this is students' mean level of stress for time 2 after they've had their American identity denied. So you can see just by eyeballing this plot here that time 2 stress levels are higher than time 1. What we don't know is that a statistically significant difference? And so that's why we're running this test, to see, is that a big enough difference to be statistically significant? And one of the things that you can look at when you're looking at this descriptive plot is if these whiskers, so these error bars, are overlapped, then it's much less likely that you're going to have a statistically significant difference. If you have gaps between these bars where they're not overlapping with each other, it is more likely that it's statistically significant, the difference between those. So we still have to look at our data because this does not confirm anything, but this gives us an idea of what is happening. And this descriptive plot here, this gives us our n size. So we're looking at a total of 65 of the 126 participants in this study. And we can see time 1, the mean was 2.86, and time 2, the mean level of stress was 3.85. So to see, is that a statistically significant difference, we have to look at our paired samples t-test results here. So what we care about are a couple things. We're going to look at this p-value first. This tells us, do we have a statistically significant difference? If this p-value is less than our alpha level of 0.05, the answer is yes, there's a significant difference. We have a p-value here that's not only less than 0.05, it's less than 0.001. So there is a very small likelihood that we would get this kind of a difference just by chance. And other information that we'll get from here are degrees of freedom and our t-statistic. We use this when we're reporting it in APA format, and I'll show you how to do that. So other information that we look at is we're going to look at our confidence interval for the mean difference. So we can see the lower bound here is negative 1.31, and the upper bound is negative 0.67. So when we're looking at confidence intervals, we want to see is 0 in that confidence interval. If we have 0 in the confidence interval, then there's a chance there's no difference, because we want that mean difference to not equal 0 for our alternative hypothesis. So if 0 is included, then that tells us maybe we don't have something significant going on. But here, 0 is not included in this confidence interval, so this is just further evidence that that p-value is telling us the right thing. The last thing we're going to look at is our effect size. So effect sizes are incredibly important because we have statistical significance is our value less than our p-value of 0.05, but we also have practical significance. How meaningful is this effect? And so we have a Cohen's d value here of negative 0.77. A small Cohen's d value is 0.2, medium to moderate effect is 0.5, and a large effect is 0.8. So we're not quite there to a large effect, but a lot of researchers may call this either a moderate effect or a moderate to large effect. So the difference in stress levels for these participants who had their American identity denied was almost large, was moderate to large. And so that means that in terms of the impact on their levels of stress, this was pretty meaningful. So let's talk about how do we report this and write this up in APA format. So this is just a brief way of reporting. So we have the general formula for APA format when we're reporting t-statistics. We have t degrees of freedom, followed by equals the t-statistic, our p-value, our Cohen's d value, and our 95% confidence interval. So here, our degrees of freedom, we're going to get that from our paired samples t-test table. So degrees of freedom here, you can see 64. So that's just n minus 1. So we had 65 total participants minus 1, 64. And then we're going to get our t-statistic also from this table. So we look under t, we can see negative 6.217. So for AP format, we're always going to, or generally going to be rounding to 2 decimal places. So here, we're going to put negative 6.22. So I'm rounding up to 0.22 to round to 2 decimal places for AP format. So next is our p-value. So our alpha level is 0.05, but we can see here our p-value is less than 0.001. So we're going to change this to that. P is less than 0.001. It's better to put the lower p-value just because, it looks more meaningful, and it also shows that this was very unlikely to happen by chance. Next is our Cohen's d value. We'll also get that from the table. Cohen's d here, negative 0.771. Also going to round that to 2 decimal places. So we will have negative 0.77. And then last is our 95% confidence interval. So the first number that goes in these brackets is always going to be the lower bound, the lower number. So negative 1.31 will go here. And then the upper bound, the second number, will always go second. So upper bound here, negative 0.673. We're going to round to 2 decimal places, negative 0.67. So now that we've talked about how to briefly report this in AP format, let's talk about what does this mean. This means that we found support statistically for what we saw in this descriptive plot here. So student stress levels time 1 at the very beginning of the study when they first got into that lab room were lower than their stress levels at time 2 after that second experimenter came into the room and denied their American identity. So we can see that students who've had their American identity denied have significantly higher levels of stress than before that happened to them. So this can be a really significant stressor on these students. And when we looked at the effect size, we saw that this was a moderate to large effect, meaning that this was pretty meaningful for the 65 students that were in this particular condition that we studied. So if you want more information about this study or about how to go through the steps for a paired samples t-test or how to write it up in AP format, I have several resources for you in the notes section of this video. So please comment with any questions that you might have, and follow those resources in case they can be of help to you.